Hi, my name is Jennifer Field, and today I will be demonstrating how skip lists work using a skip list visualizer. The first operation I will be showing is an insert of the value 20 into the skip list using the coin flip sequence 110. These coin flips show how the nodes can exist in several rows of the skip list, not just the final row with all the node values. It can be seen that the node 20 was inserted into the skip list, and the value 20 was then inserted in 2 rows above the bottom row of elements due to the sequence of coin flips that was entered. Next, we must insert the value 40. We will simulate coin flips to determine if the value is promoted on the lists above the bottom all elements lists. Because we flipped a tails, the coin flip sequence will be a 0, meaning that it will not be inserted in any rows above the bottom all elements row. Now we will insert a value of 10. I will not simulate the coin flips this time, but the program is simulated the coin flip sequence for us to determine if the value will appear on rows above the bottom. When the node 10 was being inserted, 10 was first compared to the value 20, and since 10 is less than 20, it moves down all of the rows until it reaches the bottom row of all the elements. Since the program flipped heads 0 times, that is why the value appears on 0 rows above the bottom row. Now we'll insert 20 again. This skip list will locate this value on the bottom row of elements, and it will be finished. Next, we will insert a value of 5 into the skip list. When the 5 was inserted into the skip list, it was first compared to 20, and since 20 is greater than 5, it moved down a row, and since 20 is greater than 5 again, it moved down a row, and then it reached the bottom row and was inserted in between negative infinity and 10, as it is greater than negative infinity and less than 10. This time, 5 was not inserted into any rows above the bottom row. This signifies that the coin flip sequence generated started with a tails, or a value of 0, so it was not added to any upper level rows. Next, we will insert a value of 80. First, 80 is compared to 20, and since it is greater than 20, it goes across. Then it is compared to positive infinity, and since it is less than positive infinity, it goes down a row. And then it went down another row because it is again less than positive infinity. And then finally, when it reached the bottom row, it was compared to 40 and positive infinity, and it was placed in between those two node values. Now, next, the 80 was then, the coin flip sequence generated was then a 1, 1, 1, 1, 1, 0. Thus why all of these upper rows include the node value of 80 on them. Now we will delete the element 20 from the skip list. The skip list will locate the 20 on the bottom row and remove it. It will also remove the value 20 from any upper level lists it exists in. Now we will insert 100 into the skip list. Again, the program simulates coin flips to determine its appearance on higher level rows. The 100 is first compared to negative infinity and 80, and since it is greater than 80, it moves across, and then it moves down as it is not greater than positive infinity, and it moves all the way down the skip list to the bottom row, where it is placed in between 80 and positive infinity. For the value of 100, the coin flip sequence that was generated was a 1, 0. Thus why the 100 is only seen on one row above the bottom row. Now we will insert 20 back into the skip list using the coin flip pattern 1, 0. "20 will appear in the bottom row as well as one row above the bottom, but none above that. In order to find the place that 20 should be located in on the bottom row, 20 was compared to negative infinity, and since it is greater than negative infinity but less than 80, it moved all the way down to the bottom row, where it was then compared to all of the elements in the bottom row. It was greater than 5 and greater than 10, but less than 40, so it was placed there. Again, it is located on one row above the bottom row due to the coin flip sequence 1, 0. Now we will insert a key value of 30. Again, 30 is compared to negative infinity and 80. As it is not greater than 80, but it is greater than negative infinity, the value of 30 moves down the skip list until it reaches the second to last row, where it is compared to 20 and 80. As it is greater than 20 and less than 80, it moves down right next to the 20 and is placed in between the 20 and the 40. Next, we have to delete the value 5 from the skip list. This deletion removes 5 from the bottom row and all of the upper rows that it is located in. In this case, it is not located in any upper rows, so it is only removed from the bottom row. Before 5 can be deleted, it must be located in the bottom row of elements. So in order to find it in the bottom row of elements, it was first, the path that it took was straight down the left-hand column where the negative infinity is, as 5 is less than the node value of 80, which it is being compared to, and it went all the way down to the bottom row of elements, and it was removed from the bottom row of all of the elements. Next, we will insert 50 into the skip list. As 50 is less than 80, it moves all the way down to the second to last row, where it is then compared to 20 and 30. As it is greater than 20 and 30, but not greater than 80, it moves down next to the 30 and is then compared to 40. As it is greater than 40, but less than 80, it is placed in between those two element values. Since you cannot see 50 on any row above the bottom row, it is clear that the coin flip sequence that was generated was a 0 immediately. Finally, we will use the skip list to look up the element 80. This element is located in the bottom row in the element list. In order to find this element, it is first compared to negative infinity and 80 and positive infinity. As it is not greater than positive infinity, it travels down the rows where the 80 is all the way to the bottom row, where 80 is then located in the bottom row of all of the elements. This simulation helps demonstrate why skip lists are very efficient and better than a simple linked list. On average, half of the elements of a linked list will need to be searched through to find the needed element. Skip lists help us to find elements in a time of log n, which is much faster than the time it takes a simple linked list. A simple linked list will take a linear runtime of n. This is much slower than a runtime of log n. Therefore, skip lists are a very efficient way to sort elements.